So welcome to the Oxford 13 Cultural Astronomy School. This is the first time we've held one of these conferences here in Australia, and we're excited about getting things kicked off over the next few days. So I want to extend a warm welcome to all of our visitors, both local and international. I do want to say that we are meeting on the lands of the Wurundjeri people of the Eastern Kulin Nation. And I want to pay respects to those elders, past and present. And I want to extend that warm welcome and recognition to all other Indigenous First Nations elders and colleagues who are with us today. So it's going to be a really exciting agenda over the next 3 days. Today is going to be a bit more of a focus on archaeoastronomy and theory. What we're going to do is we're going to have our first 90-minute session. We're going to have a coffee break. So coffee's on you, but we can go over to University House where you can use these. Get your membership discount. And the coffees are much cheaper there, trust me. You can also go downstairs or behind us to Dr. Dax. We'll come back here, have another session. Then we're going to have lunch at University House. I've ordered us all box lunches. It seems I ordered many more box lunches than we have people to eat them. So if you're hungry, you're going to be in good hands this afternoon. We're going to come back and have another session. Then at 2:30, we're en masse going to migrate down to the law building, which is where the conference is going to be held next week. And we're going to get on a shuttle bus. We're going out to the planetarium in Spotswood. And we're going to do some fun stuff there. They've donated their time to let us come out there and see a couple shows and do some things. Then when we come back, we're going to migrate back up to University House right over here. We're going to have our conference dinner and our trivia hosted by Dr. Gerard Wiesenfeld. So it's going to be an exciting day. Tomorrow, we'll have some sessions, but tomorrow evening will be free. Nothing going on tomorrow evening. Got a nice, relaxed evening to yourself. There aren't going to be many of those throughout the conference. And then Friday, of course, Friday evening, Professor Clive Ruggles will be giving a public lecture on Pacific sky knowledge as part of the July lectures in physics. You do need a ticket. They're free, but you need to book a ticket. They're going to be in person and live streamed. And I think so far tickets are pushing over 300 already. So it's going to be a nice big crowd. And then we have lots of exciting stuff going on next week. So again, I want to mention we're on Wurundjeri land, but I did want to extend a huge thank you to all of the sponsors. We had quite a few organizations contribute cash and in-kind and discount support to us, which has been phenomenal. They've really helped pick things up because the fee for this event and for the conference doesn't cover our base costs, because the idea was to make it as accessible and inexpensive as possible, especially since we're really trying to bring in First Nations and Global South communities. So they've helped fill the gap with their donations. So a huge thanks to all of them. We are going to have signed, printed certificates for everybody who attends the school. So Jarita, we're going to have to sign a lot of them by hand, but those will probably get in the next couple of days. I have to print them off. But then the bags and all the goodies are all going to come on Monday. So what I'd like to do is go ahead and kick this off by introducing Professor Clive Ruggles, who I think for most of us doesn't need an introduction, but Clive has been the primary foundational member of this organization, this conference series, for going on 40, 50 years now, very long time. That's right. So Clive is going to talk to us a bit today about cultural astronomy the last 50 years. So Clive, please.
Thanks.
Oh, this in your pocket?
I was so impressed about how you were projecting your voice there.
Well, I can do that too.
Right, let's get this one on. And if we can do... Absolutely, you're ahead of me. Okay. Okay, can everyone hear me all right? And my advanced button, is that one okay? Oh, it's a Mac. Great. Okay. Yeah, so I thought I might start by establishing my credentials for talking about the last 50 years. And a good way to do that is to show me actually surveying this megalithic site in Scotland a little bit more than 50 years ago. Can you spot me, the one in the white trousers there? And three of my colleagues who were with me. This is a megalithic site. It's more than 4,000 years old, and it was claimed to be a solar observatory back in the day. The other thing that might be of interest to one or two people here, you see that little head bobbing up just on the horizon there. The day that we chose back in 73 to do the survey, we were in the middle of it, and this guy whose head is just in the picture there by accident happens to be wandering up. He's American, and he introduces himself. Hey, I'm writing a book about megaliths and astronomy, he said. I'm going to take a photograph of you and put you in it. And we thought, hey, yeah, sure. And his name was Ed Krupp. And he's someone who is known to a few of you here as a big name in the field. And hey, and I saw him again 2 weeks ago in Ireland. And yeah, he's still going strong. So that was one of my life's complete coincidences. And the other thing about, if you're interested in me 50 years ago, that's what I looked like, incredible though it may seem. Anyway, thank you. So I could focus on a number of things going back over the 50 years. I could focus on theory. I'm not going to do that. There's other people speaking after me who'll talk about theory. I could focus on practice, best practice, bad things, and so on. But I've decided I'm going to particularly focus on method. It's been my thing over the years, how we approach the different evidence and how we reach conclusions. So that's my focus, and a little subtext to this, encouraged along, I may say, by Dwayne on this, was, are we still going around the same circles? Now, I promise you, there will be no more bad plays on words in this presentation, but you can see that is a stone circle in Ireland. And I'll talk about how whether we are still making some of the same mistakes as we go through. This was actually a title of a paper I presented at the 9th Oxford Symposium. This is in Lima in 2011. Anyway, back to the 1970s. What was going on in the 1970s when I got started in this field? Well, at the centre of a big debate back in the UK, back in Britain, was this guy called Alexander Thom. He was an engineering professor at Oxford, but he had a big side interest in megalithic sites, the prehistoric Neolithic sites in Scotland, which he claimed were megalithic observatories, his term. And what he was saying was really very intriguing. His idea was that if you stood yourself at a particular place with a natural horizon, like this one here, and this is a site called Kintraw, the point is, if you're trying to pinpoint the solstice, the place where the sun rises or sets at the solstice is only ever so slightly different from where it would rise or set a day or two later. Normally, that difference would be imperceptible in a normal landscape. But if you positioned yourself right with respect to the natural horizon, on one day, you might, for example, see the sun setting like this, and you see how it goes down, and you lose it behind the mountain, and you've lost it. But a day later, it might only be different by something like a 50th of its diameter, slightly higher. And on that day, that difference means that you'll catch a glint of the sun in a notch in the horizon. And it was Thom's idea that people in the prehistoric past in Britain used the natural horizon as an observing instrument to obtain precise observations of the sun, determine the solstice. It was a fantastic idea. And he elaborated it. His idea was that there was a whole megalithic calendar, as he called it, in operation around Scotland at the time, different sites marking different dates in the year, dividing the year up into exactly 8 different parts, equal numbers of days, perhaps even 16. And he had a lot of statistical evidence to back it up. So, here it is. That curvigram, that sort of probability histogram, which we still some of us use these days, that sort of way of presenting evidence and examining it, he pioneered that. And basically, I don't want to go into the details, but he had a lot of statistical evidence to back up his ideas. He went to 276 sites in Scotland to feed into that. But archaeologists generally were skeptical. Most astronomers and people from the numerate sciences were really, really enamored by this idea and really excited by it. Archaeologists were much, much more skeptical. They didn't understand the maths, most of them, but somehow it just didn't gel with their social models of people in the past. And what made it worse was Tom's own attempts to put in the cultural background to this. He talked about megalithic man. That was his concept. And as he says here, in his view, people in the past was a competent engineer who had extensive knowledge of practical geometry, studied the motion of the sun on the moon in great detail. And any archaeologist or anthropologist will look at this and say, this is ethnocentrism. This is seeing ourselves in the past, reflected in the past. And basically, what Tom's work did was to open up a huge gap between, on the one hand, mainly astronomers, engineers, and others, and on the other side, archaeologists, people from the humanities, who saw the same evidence but reached completely different conclusions. On one side, megalithic observatories. On the other side, this had nothing to do with astronomy at all. All that was going on in the UK, particularly in the 70s. But also something else was going on rather differently in Central America, really starting in the Mayan world particularly. And the difference, critical difference, was that in the Mayan world, there was written evidence. And particularly one of the codices that was rescued from the fires of the European colonizers turned up in Dresden, hence its name, a few hundred years later, the Dresden Codex. And that contains a lot of astronomical information. What you see here is tables of motions of Venus and the eclipse table, as known. And all those dots and dashes are numbers, numerals. The Mayans had a base 20 counting system. You can see in there, if you know where to look, the periods, in fact, they're here, the periods of disappearance and appearance of Venus, so its cycle. They knew a lot, and it's all evidenced here. That, together with ethnohistory, so evidence of what the early colonizers, those who recorded what they were seeing before it got destroyed, that ethnohistory also feeds into that. And that gave people who were working in Mexico a very different perspective. And it was into that background that archaeoastronomy really launched itself. And in fact, two journals, both launched in the year 1979, a British one, the one on the left, and an American one, on the one on the right. And both of those existed for many years, a few decades after that. The name archaeoastronomy, it actually had first been used about a decade earlier, but it came about, I think, largely because going back 15 years, we come to a book called Stonehenge Decoded, which was very controversial by that guy you see there, Gerald Hawkins. And that by this time, no one seriously believed the ideas of Gerald Hawkins about Stonehenge. They had been pretty comprehensively critiqued. And what Gerald called but his ideas were very popular because he'd written a popular book that sold millions of copies. And what he described what he did as astroarchaeology. And I think that the reason that people in the 70s wanted to call what they did archaeoastronomy was to distance themselves from that largely. And that's how the term came about. And it came into dictionaries and things. So you'll see many definitions of archaeoastronomy, but this is the one I use and have used for a long time. And the important thing about this, in my view, is that last phrase and the uses to which people's knowledge was put. It's not just about collecting evidence of some astronomical phenomenon. It's about what that meant culturally. And that's what makes what we do meaningful. So we move on to the 1980s. And the big event that started the 1980s was the first of these Oxford conferences, which was in Oxford, hence the name. Right, can everyone see me in that? Yeah, so hey, so people on the, yeah, so go along. Yeah, the guy, the black beard, I'm the one on the right with the moustache. Did I really have a moustache like that? But I did, yeah. Anyway, and there might be one or two other people that people vaguely recognize in there. So that was the first conference that brought these two sides together and brought the mainly British, but some other European archaeoastronomers together with the mainly North American, Mesoamerican archaeoastronomers, brought us together for the first time. And there were two books, two conference proceedings came out of that conference, and they were called Archaeoastronomy in the Old World with a green cover and Archaeoastronomy in the New World with a brown cover. And this gave rise to what for the next 15 or 20 years became known as green archaeoastronomy, brown archaeoastronomy. It's rather sad, really, but this happened. And it basically, these two types of archaeoastronomy epitomized what we were doing. On the green side, we were all worried about selection effects, being statistical, being objective with the data, making sure that we weren't just choosing the alignments on the horizon that fitted and ignoring other ones. We were data-driven. That's what we were focusing on. Meanwhile, over in Mesoamerica, they had a completely different approach because of the ethnohistory, because of the written evidence, and they took a much more anthropological approach to interpreting the evidence. So on the green side, I mean, the basic problem is obvious, and I show you this stone circle illustrated. It's a beautiful little stone circle in the south of Ireland, and it's aligned on the winter solstice sunset. So the sun sets in the northern hemisphere, it's setting down like this, and it sets into that little notch in the horizon. Actually, the arrow is pointing along, I didn't realize that. Shifted the picture and not the where it's winter solstice sunset should be right under the alignment and into that little notch. Oops. I don't know whether you people online can see when I'm pointing at things, but let's hope you can. Anyway, now that's all very well and good, and that's been noted for many years. But actually, that little stone circle is one of a group of about 60 or 70 stone circles of a similar type and design in the south of Ireland, built at a similar time. And when you look at them as a group, sure, you see a broad pattern of orientation. You can see in that blue diagram that sort of pattern, but there's 50 or 60 examples. But this one, Drombeg in the top left, is the only one that's solstitially aligned. All the others are spread. And if you think about that statistically, you then think, well, hang on, we're just selecting the one that happens to be solstitial, ignoring all the rest. That's not what it's about. Yes, there's a broad pattern, but we're wrong to think that that was deliberately solstitial. So, and that's how the sort of statistical argument went. And so during the 80s, on the green side of things, we became very prepossessed with groups of similar monuments, trying to look for patterns so that we could actually statistically verify what we were doing. One such group were these things, another type of stone circle, this time in the northeast of Scotland. And there were about 70 of these, and to cut a long story short, their orientations seemed to fit a pattern related to the moon. And hence, we had the idea that these were some sort of ceremonial sites where people came and observed the moon, perhaps being aware of 19-year cycles of the moon and having special ceremonies. In fact, that idea with these sites, the idea of ceremonies has been knocked on the head since then by 3 archaeological excavations that have shown that, in fact, these sites were originally cairns, originally tombs, which were surrounded by a stone circle, and those tombs degraded. And 3 sites have been excavated and shown that. So we now think it's more likely to be a practice. It may be related to the moon, but it's a practice to do with setting up these sites rather than repeated ceremonials. Anyway, groups of monuments was where we were focusing on the green side of things. But to give you an example of how arguments went on the brown side of things, yes, they were interested in monuments too. And here's an example, Uxmal, a Mayan site in the Yucatan in Mexico. And you can see on the plan there, there's one building. It's called the Governor's Palace. That's a modern name and term for it, but it's a building which has a slightly different orientation. And it was noticed by some of the American archaeoastronomers that that building was aligned upon the rising point, the most southerly rising point of the planet Venus. Now, the thing about planets and their rising and setting points is they're rather similar to the sun and the moon. They're all vaguely in the same plane. And the planets move around a lot. So, the southernmost rising of Venus changes from cycle to cycle quite considerably. But the thing is, in the case of Mayan monuments, we have long count dates, basically in stone. We have the date of the monument. It's known the date of this monument converts to, I can't remember the exact date, I think it was 923. It was certainly in the 10th century AD. So we know the year it was built. And so we know where Venus was rising. And it does align with the southernmost rising of Venus, also with the northernmost setting in the other direction. But even so, one alignment, one building aligning on Venus. Now, on the green approach, we would have laughed that out of court. One alignment, no, not repeated. We couldn't consider it. But the building is covered in glyphs. And even then, the meaning of some of these glyphs was known. This was before the Mayan hieroglyphics were fully translated, or more fully recently. But even so, we knew then this building is covered in Venus glyphs. If you were a Mayan, it's kind of says Venus in neon lights on the front, right? It's covered in Venus glyphs. It's a Venus building. That, together with the fact that we know from the written evidence that the Mayans were very, very interested in Venus. It was a huge, important part of their whole temporal cycle. So we know Venus was important generally. We know Venus was important in that building. So we believe that. Except there's the arguments continued about which direction of that alignment and so on. So you see a very different approach because we had that broader context in Mesoamerica. Also during the 1980s, we had the beginning of the interest in more indigenous practices related to astronomy. Now, anthropologists have been looking at stuff for a while, but suddenly coming into some of the meetings on archaeoastronomy were people talking about modern practices. And I remember this particular one, someone talking at one of the conferences about string figures in the Pacific. Extraordinary how people can create constellations using different string figures. This is from the Trobriand Islands. And there was an attempt to call this blue archaeoastronomy. I don't know what happened to the blue color. There's something funny about the colors here, but that orange should be a blue. It was in my version. Who knows? Anyway, that is blue, guys. Okay. But of course, this is really a bit of come on. This is so the term ethnoastronomy came along. Now, people tend to attribute this term to a paper that was written called Archaeoastronomy and Ethnoastronomy so far that came out in, I think, 1973. But actually, I've traced the term being used back into the 1950s now in other sources. So the term had been around for some while. One of the seminal works in ethnoastronomy, if I can call it that then, was a book by Gary Urton, that he wrote that he published in 1981. It was about his experiences in an Andean village in Peru, Mizminay, and he lived there for a couple of years. It was a pretty isolated village in those days, and he basically lived with the people, and he was particularly interested in their knowledge of the skies and the calendar and so on. And part of that was about the risings and settings of different stars and the sun on the horizon, and how that helped their calendar, their agricultural cycles. But also another aspect of this was the whole layout of their village reflected their view of the cosmos. There were 4 paths in the village, and the little church in the middle, which had previously been a temple, in the middle. Those 4 paths were reflecting the Milky Way, because at that latitude, it's about 11 degrees south. And you really have to be in a planetarium to see this. I still can't visualize this. You find if you look at that in a planetarium, you'll see the Milky Way sort of spends a lot of time going overhead like this. And then over its daily cycle, it sort of shifts over, then suddenly goes around to the horizon, then comes up the other way. And it's sort of in that quarter for about a few hours. So you see the Milky Way is sometimes here, and then it goes, and then it's here. And as I say, even I have to see that in the planetarium to believe it's the case. But the point is they reflect that in their cosmology. It's their cosmology. Their understanding of the cosmos is that the Milky Way there, it's a river in the sky, and they actually put the earthly rivers, they have rerouted them to go along paths into the river so that they reflect that on the ground. Cosmology. This is building things in reflection of your understanding of the cosmos. And that sort of input was really important for people who were really studying more deep past and didn't have that sort of input. Those ideas of how astronomy might be used in practice. Another one that came in, and I remember this was a paper about this in the Oxford 2 proceedings, the middle of the 80s, from an indigenous group in Colombia in the Amazon. And what the particular interest here was in that little Caterpillar Jaguar constellation. And again, Caterpillar Jaguar, the qualities of the constellations are very different from our categorization of things. The point about the Caterpillar Jaguar being, well, it's the caterpillar aspect of it. There was a time of year when the Barasana, who are hunter-gatherers, would need to be in a certain part of the forest under certain trees, because at that time of year, caterpillars or their pupae started to drop from trees, and they're an important food source. How did they know when to go there, what time of year? They looked at the caterpillar in the sky, and the caterpillar in the sky started to come down in the afternoons at a certain time of year, and that was when the earthly caterpillars started to come down from the trees. We can see in a Western view why that works. It's to do with the fact that the caterpillars pupate at a certain time of year, and it coincides with approximately the heliacal set of part of Scorpius is their caterpillar constellation. But of course, in their worldview, there's a direct connection between the sky caterpillar and the earthly caterpillars. It's another way of viewing the world. It's a different sort of making sense of your cosmos. We do it in the Western way, using Linnaean classifications. If it's in the sky, it's up there, it's astronomy. If it's down here and moving about, it's biology, and so on. But of course, other people make sense of the world they're in by making connections in different ways. This one can be understood in a Western context. And it was that idea, and many of us here know of other examples that are similar to that. Again, this idea that things are viewed in a different way. And also, just to show that, of course, it's in a very, very rich context of other understanding of the cosmos and other constellations and things going on in the sky. And the sky is an active place. It's not just a passive place where you look and see what's going on. It's somewhere you can influence. It has living beings and so on. And the other thing I just wanted to mention that came up in the 1980s with other lessons is the Morsi, which is something I was privileged to work on. I never went out to Ethiopia, but I was privileged to work with this guy, David Turton, who was an anthropologist who British anthropologist, worked out with the Morsi for 2 or 3 years, and he had a lot of field work. Stuff to do with astronomy that he wanted to discuss and work through. Now, the Morsi country looked like this. I mean, there have been so many changes since because of droughts and so on. But back in the 70s, they were largely isolated, and they had been when David was there. And you see, there were cattle herders and pastoralists by the side of the Omo River in the southwest of Ethiopia. And they're transhumant. So there's an annual cycle. Part of the year, they do a cultivation of sorghum down by the river. And the other part of the year, they go up into the highlands and they manage the cattle up there. So they come to and fro. Now, if you ask any of the Morsi, as David did, about their calendar, they would tell you, they'd sing you a song, basically, and even the kids knew this song. And it was about the beargoo. The beargoo is their word. Essentially, the beargoo is an entity like a little baby. That when the beargoo is one, you've had a month gone. Beargoo is two, another month. And every year the beargoo renews. And so there would be things like beargoo 8, the first, and everyone tells you that when the beargoo is 8, the rains fall, the big rains fall, and so on. And when beargoo is 1, we plant the sorghum, and so on. So all that is all very clear. One thing that's curious, these are lunar months, lunar phase cycle months. And there's 12.5-ish of those in a year. So you think, well, hang on, there must be some sort of intercalation going on. There must be some years when they need 13. And there's never any mention of a 13-month. But actually, when you look into it, there is a named month, Gamway, when the beargoo is essentially 0. So in fact, they have a 13-month year, but they don't sort of talk about Gamway in this cycle until you prompt them. But you've still got the same problem. So every year they have a 13 months, but only 12.5 fit in the year. How does this work? Why doesn't it get out of step? No one ever talks, that's how it is. Well, the answer comes in their social practice, that they basically do everything by debate and consensus. And this is a debate about war against a neighboring tribe, in fact, but they do this about everything. And so what David found, he'd get people sing this song and they'd say, well, what month is it? What's the age of the beargoo now? What month is it? Oh, I don't know. Go and ask such and such. They're an expert on the beargoo. They'll tell you. And he goes across. Ask someone else. Oh, I don't know. There was that. What's not man? He would tell you if he was alive still, but he isn't. And what he soon found is that no one actually really quite knows what the beargoo is. And then people would say, well, it might be 7 or it might be 8. Go and ask that person over there. And so there was actually always different opinions around the place. Even though everyone believed there was a right answer, no one really knew it. And okay, you say, well, surely when the big rains come, then everyone knows it's month 8, don't they? That's what they sing about. Well, no, because everyone knows that sometimes the big rains are a bit late or a bit early. And so what actually happens in practice is that the various events change the balance of opinion, and they will debate sometimes which month it is, and some people will go along with that, and some people retain their own opinions. It's always done by consensus and debate, which to us, again, a Western view seems, wait a minute, this is haphazard, this is just, not good. But it's absolutely right for that context. It works. And another mistake is, well, actually, there were 1 or 2 people in this tribe who in this group who watched the sun rising. You say, okay, so we've got experts. This is interesting. Western view coming in here, right? Experts who actually know about the sun rising along the mountains. And one of these people talked to David and described, and 2 or 3 of them did, but this particular one, and said basically the sun goes into its downstream house for about 3 or 4 weeks when it appears to rise in the same place every morning. And then it goes down to its upstream house. And it goes into its downstream house when the beargoo is 5, and in the first half of the month. And it comes out when the beargoo is 6 in the first half of that month. Now, wait a minute. As we all know, the sun must go into its house sometimes in the second half of the month, not in the first half of the month. So what does that person say then? Oh, well, the sun's a bit late going into its house this year. Or the sun, because, we know that the sun is actually related to the seasons, but in their view, the sun is just as much a seasonal indicator like birds and flowers and other things, and no more reliable. Why should they think it is? Again, raising lots of questions about how we have to rethink, if we're thinking about what the observations of the sun or the moon meant in the past. And the other thing I wanted to say, and you didn't really think you were going to be, I'm going to start showing you pictures of goat entrails, but here we are, because the experts in watching the sun were also experts in provenancing the future from goat entrails, and the 2 interests tended to go together, which I think puts it in another important context there. And I think what this teaches us that we've got to be so beware of starting to talk about a path of progress up to, what we in the West do, And you would see this in history of astronomy books. In fact, you would still see this stuff back in the 2000s in history of astronomy books about the progress of calendars, as if it was an almost inevitable. So from sort of early days, where calendars are lunar, the lunar phase cycle is the most obvious cycle in the sky. And true, many indigenous calendars are basically lunar. You count the lunar months from the new moon. And then as things develop in this view, then people can calibrate this by solar observations, as the ancient Egyptians did, or with stars, as they did looking at Sirius. And so you use that to calibrate the months, and you develop lunisolar calendars. And then eventually you get to where the Babylonians were, where you record stuff and you adopt a numerical algorithm instead to intercalate the months, in a nice cycle that fits. But what examples like the Morsi tell you is that there's other ways of doing it that are equally appropriate. It's wrong to sort of think about paths of progress. And similarly, horizon calendars, just the modern examples, the Hopi is just one there. They have many functions, and some of them may be timing agricultural things, timing ceremonial things. What makes a point of sunrise on the horizon important? Well, it may be that the sun rises over a sacred mountain on that day, and that becomes a ceremony of big importance. Or it may be that's a good day to plant things. There are a whole mix of different things. But just one last thing about the Morsi. I'm going on a bit about the Morsi because I know a lot about that. But there is one point in the calendar, in the Morsi calendar, when they have to do something exactly. And that is to do with going down to the river. When basically the tribe splits apart at that point, the cattle have to be taken from the mid-range away from the river because of tsetse fly. But the women generally come down to the river, and that's when they need to plant the sorghum. The problem is that the river goes up and down and floods several times. If they plant the sorghum more than a couple of weeks after the last flood, the ground's too dry and the seeds don't germinate. If they plant the sorghum too early, before the last flood, then the last flood's going to wash them away. And they have to get there within about a week or two, the right time. How on earth do they do that, given the calendar? Well, they use stars just for that. And what they use is the 4 stars. It's actually 2 of the Southern Cross and the pointers there. And they look at what's effectively the heliacal set, the stars disappearing in the evening sky. And you see they have names for those 4 stars, their own names, Imai, Doi, Wa, Sholbi, all of which are the names of things related to them, the petals of a flower and so on, relating. And when that star disappears, that relates to a natural event. And when the Sholbi disappears, that's when the river falls for the last time, and they know they can plant. It works. We know that the rising of the Oma River is very, very closely related to the year. That's just known, and it's true. And so they've noticed this correlation. And so for that, again, it's not that they think, oh, now we've got to be exact about this, we'll use the stars. It's that they realize that the stars are correlated with that event, and they use those to indicate it. And you'll see the Western names of those stars. You'll notice that Imai is called Imai. And that's because 10 years ago, the international community, the International Astronomical Union, who names stars for the Western world, decided to use, there was no name for Delta Crucis, the faintest of the Southern Cross stars. And it was decided to use the Morsi name for Delta Crucis. So Imai has actually become the international name for Delta Crucis now. So moving on to the 1990s, I'm keeping an eye on the time. So the 1990s, well, they brought along the 3rd Oxford Conference, and they also brought in this term cultural astronomy. And the conference, we'd actually had Oxford 2 in Mexico, but Oxford 3 was back in the UK, and I organised that one in Scotland. And I delivered the opening paper at that with a colleague, Nick Saunders, who's an anthropologist. And that was where we proposed the term cultural astronomy. And that stuff in quotes is what we said about it. And so that's good. Oh, by the way, now I noticed that the two books of that conference, that you can buy them on Amazon and various other on the internet, and they're about $200 each now, I think US dollars. And I thought this is crazy because I've actually brought along a spare copy of mine, and it suddenly occurred to me what I might like to do, if this is all right with yourselves, is to auction them. And the idea being that I would any profit that comes to the auction goes to a charity that we run. It's called the Alice Ruggles Trust. And so the idea would be that I would like to auction them off, and any profits go to our charity. So I'll bring them out. I've actually got a second copy of the right-hand book there, if anyone wants to go for that one on its own. Anyway, so those two books, and of course in the blue one, you get the paper in which we propose the term. The other thing that started happening in the 1990s was the organizations were set up. So the European Society for Astronomy and Culture, SEAC, kicked off in 1993. There'd been a few meetings going on in Strasbourg in France before that, which led to that creation. But the actual meeting was set up in Bulgaria at a meeting in 1993. Isaac itself was set up at the time of the sixth Oxford Conference in 1996, no, the fifth, or following that. And Isaac's been going since then. And then the Inter-American SEAC started up shortly afterwards, a few years later. So we started to have these organizations which are still going strong now, and SEAC also has its annual meetings, as does SEAC. So various things coming along. One thing that began to lose favor, fortunately, in the 90s was the idea of ancient observatories. People kept on and on about sites being ancient observatories. And you would see, in fact, you can still see some of this on the internet now, sites such as these being described as ancient observatories. Now, none of them is really provenly an ancient observatory at all. The Korean site, Cheongdai, as far as we know, is yes, it was some sort of sky watching tower. People may have stood on the tower or stood by it to watch the skies, but it had a lot of other functions, religious functions as well. The Caracol in Mexico, that is debated furiously by archaeoastronomers on the basis, just because it looks round, which is unusual for a Mayan building, and it has this sort of dome-shaped top. It kind of looks like a modern observatory. It doesn't mean it was an observatory at all, but it certainly had windows around it for looking out. Do those windows align with significant events for the Mayan? Well, I think I would say the jury's still out on that. People have argued it both ways. Newgrange in Ireland, I'll mention a little bit going on, but that is a tomb. It's a Neolithic tomb. It's not an observatory. It's solstitially aligned. People call it. And then going back to this site in Germany at Goseck, which is older than any of them, some sort of ceremonial meeting site with 3 entrances. It's been very nicely reconstructed and so on. You go there. Whether, again, it happens that 2 of those entrances broadly align with the solstices. Does that mean it was an observatory? No, the problem with the word observatory is that it implies that a place was built purely or mainly for the purpose of observing astronomical things. And I think with many of these cases, the symbolism related to, or practices related to astronomy, they're part of a much more complex function of places. And I think that's true of Goseck, which was some sort of meeting place, very possibly a big ceremonial meeting place, amongst many other things. And on the methodological thing, I want to just mention this group of structures, and again in the Mayan world, this time in Guatemala. And if anyone knows about these, I'm going to very much simplify what anthropologists these days discuss about the sites, just to make a point. Now, they're called Group E structures because at one of the sites in the Petén, Oaxactún, a particular structure was the fifth group of structures to be excavated in the 1940s, hence Group A, B, C, D. That's why it was called Group B originally at Wahatun. And it had a particular design. So it had a pyramid, and then to the east of that pyramid was a platform with three smaller structures on top. And it had been known since the 1940s, this was first noted in the 1940s, that if you stood on the middle of the staircase and the pyramid on the west, then the other buildings lined up beautifully with the two solstice sunrises and the equinox sunrise to the east in the middle. And this was quite this had been noted for many decades. But then during the 80s, by this time, many other similar structures had been noticed at other sites in the Pétain. And they started to be called Group E structures, right? But all of them had the similarity of design, that they were one pyramid and then this platform with sometimes two, sometimes three structures to the east. But virtually none of the others had exactly the same orientation. So it becomes, if you look at it from a green perspective here, it becomes a bit like those stone circles in Ireland. And you think, well, actually, just for a minute. So if we adopt a green approach, we're not going to believe this, because there are plenty of these sites, 50 or so of them, and none of them exactly, they're all broadly west-east, but none of them exactly is like this. But then anthropologists got involved, and particularly some work by the American archaeoastronomer Tony Avini was interested in this. And the thing about some of these Mayan structures is it was the practice to rebuild pyramids and build bigger pyramids over existing ones on a cycle. And this site was originally built about 220 AD, I think. And then it was renewed and expanded twice. And once the new pyramid was built over the small, this one, the alignment no longer worked. And you have a chronology of these sort of sites being built over several centuries, in fact. And so what became argued then was, well, maybe this group of structures, yes, the early ones did actually align, or the early phases of them did align with these events, and people would observe the sun rising. But this, whatever ceremonial was attached to those events, didn't need to be reinforced by actual observations going forward. And people built mimic sites for similar purposes, but without the actual alignments in them, as indeed this site itself became going forward. The alignments no longer worked in later stages. From an anthropological point of view, that's quite a strong argument. It's more plausible, people being people, that this would change the broad purpose related to the sun and ceremonial stays the same, but the need to keep reinforcing that with actual observations goes away, because people know what these things are for. Anthropologically, that makes quite good sense as an argument, yes. But of course, from a green perspective, you think, well, hang on, this is just being subjective with the evidence, because we're now saying, okay, if the site aligns, we're going to say that's one of the early ones, and then if the site doesn't align, we can say it's one of the later ones where that didn't matter anymore, and we're now being subjective. And you see how the two arguments play against each other. And I think what we're constantly doing in archaeoastronomy is trying to balance, on the one hand, not being totally subjective with evidence, because we have to look at evidence, but at the same time, we have to be more cultural, more anthropological in interpreting it. We're not dealing with laws of the universe here. We're dealing with people, and people, however strong a tradition, will do things in their own way, and traditions change, and everything means something different to different people. And we have to bear that in mind too. Somehow it's all about that balance. And of course, the other thing that comes up is we start to think about why, and this question of why. So if we go back to some of these prehistoric alignments, well, let's start to think about the question why. And, on the green side, people really didn't start to do this too much until about the 1990s. Let's look at Newgrange, because I think that's quite a key site in this. So Newgrange is a 5,000-year-old Neolithic tomb in Ireland. And it's famous because, well, it's a huge tomb. It's about 60 meters in diameter. And it has in the center 3 burial chambers where people place the bones of the dead over a period of time. And it has a 20-meter long corridor that leads into that, where the 3 chambers are. And of course, the place for nearly all the time is dark. But if you go there just after dawn, around the winter solstice, the December solstice in the Northern Hemisphere, so for a few days around that shortest day of the year, just after it rises, the sun shines right in to the center through a special opening above the entrance. It's a roof box called, and the light shines in and lit up the floor of these chambers for a few minutes. That was designed so that when the tomb, people's entrance to the tomb was blocked off, which it was the practice to block these tombs after a period of use, but the light still got in at the solstices, even after living people never went in there. Now, this was not any sort of observatory. You cannot imagine people, okay, I wonder if it's the shortest day of the year. Yeah, I know, I'll go to that tomb. It's smelly in here. Oh, yeah, oh no, it's not quite. Of course not. It wasn't any sort of observatory. It was a tomb. So what do we make of this alignment? And I think what that tells us, what it tells us is there was some connection in people's minds between, on the one hand, death, ancestor spirits, and on the other hand, the sun, seasons, seasonal renewal. And that connection. Now, of course, we can speculate, and we can only speculate what that meant to people. Maybe they believed that the sun shining in helped to release the ancestor spirits and hence turn the sun round and ensure that everything would grow again in the new season. We don't know that, but we know that connection existed. And I think that's important to us. And people around the 1990s started to debate about these, the meaning of things, and also about cosmological associations. There was a big debate in Britain about Iron Age. Now, this is only 3,000 years old. Round houses, these were the typical form of house in the Iron Age. That's a reconstruction. All over Britain, we find these in other parts of Europe. And there are certain parts of Britain, particularly, where there's a predominant orientation to the southeast. And the argument was, well, maybe that's something cosmological. Maybe the southeast meant something particularly to do with the sunrise aligning on the sunrise. And there are precedents for that. And one of the precedents comes from the Navajo in indigenous America. The Navajo cosmos is divided into 4 quarters. Broadly in the cardinal directions, each quarter has its own qualities. There are things you do in certain quarters of the cosmos to keep everything in harmony. And the traditional house, the Hogan, reflects that in various ways. There are things you do in certain parts of the Hogan. And the Hogans have their entrances to the east. For that reason, so is all in harmony with that. And of course, east means broadly anywhere in that sort of quarter will do. And if an archaeologist came along in the future and looked at the orientations of Hogans, they'd probably find a spread around that eastern direction. But it's reflecting that cosmological, that understanding of the cosmos. So back at the Iron Age, people started to say, well, maybe that's what the southeasterly orientation was all about. Then other people argued, well, hang on a minute, isn't it more likely to be something just purely practical? Because cold winter's morning, the wind is coming predominantly from the west, so you have your entrance to the east for shelter, and also you want to catch the early morning sun rising to warm up the house, so there's a practical aspect to that. And they argued, was it practical, was it cosmological? And of course the two are not exclusive. It could be both. Let's pass on to the 2000s. So I've been talking about how, in a sense, the more anthropological approach helps to balance out. We can't be too objective with the data, too data. We mustn't ignore the data that we've got archaeologically, but we can't just be purely statistical. We have to think about viable anthropological interpretations of that. So that balance was going on. And then early in the 2000s, along came a very different approach, going right back to the data-driven approach. And this was due to a British Actually a historian of science, Michael Hoskin, who many people here will remember. And Michael edited a journal for the history of astronomy. That was his field, history of astronomy. But in his retirement, he got interested in archaeoastronomy, and he started to look at tombs and temples around Western Europe and Western Mediterranean Europe. So particularly in Spain and Portugal, in the Mediterranean islands, and in southern France, that sort of area. And he actually, over a few years, measured purely the orientation. All he did was go along with a compass and carefully measure the orientation of each of these monuments where it had a principal axis. Some of them were tombs, some of them were temple sites. That's a particularly type of tomb giants that you find in Sardinia. And what he found was that each group, and I should say he measured over 3,000 of these over a period of about 15 years. And what he found was that virtually every local group of monuments that were similar in design, so there might be 50 monuments in a local area that looked pretty similar, like these ones in Sardinia. Every group of monuments had a distinctive orientation signature. And they're usually quite broad, like this one. So here are the orientations of these tombs of giants. And they're going round from northeast round to south, broadly speaking, with one or two exceptions, maybe nothing facing west or north. And what he found over the whole, so first of all, we're thinking that, wait a minute, this means orientation actually was important to people. Just like in any particular place in Western Europe at a certain particular time in prehistory, people were building monuments in a certain way, using certain local materials, certain design, and that design was followed. But basically, Hoskin's work showed fundamentally that orientation was something that was important within that, and it was an important part of the design. And more than that, because you get a similar orientation over a regional area, that orientation couldn't be explained by things like topography or prevailing winds, because the area was too broad and these factors changed. It could only be explained broadly to do with astronomy. And what he found was that the orientation signatures, if you like, of these different groups of monuments tended to fall within 2 or 3 of these different parts of the horizon. I have noticed that we're missing a color on here, which might be something worth noticing in the future. So I think blue has sort of disappeared from all these slides. You may have noticed that going forward, but anyway, I've only just noticed it now. But hey. Yeah, so in the north, remember in the northern hemisphere, so in the north, you never see the sun. You never see it rising or setting in the north. I think at most 6, I think it was fewer than that, out of these 3,000 odd temples faced that way. None of them effectively faced in that sector. Some of them faced in the sun rising, sun climbing, those 2 sectors, like the ones I was just showing you. There are others that were oriented in the sun descending, sun setting over to the west, and others in the sun climbing, sun descending to the south, but always broadly within those categories. And that was a main argument for saying that many of these tombs and temples, and we're talking over 2,000 years of prehistory in different parts of Europe, different traditions, but all of them had this broad correlation with the sun, just a broad one. And amongst those were particular examples, and this is the best example. Anta is the Portuguese word for dolmen. So these dolmens, they're very old. They're from the 4th millennium BC, so we're talking 6,000 years old now. Mainly found in central Portugal, parts of western Spain, adjacent. These were built with these were burial mounds, so they were originally covered in earth and so on, but they had a corridor. They were built in a particular way with 7 upright stones leaning against each other and a capstone on top, facing out in one direction. Every single one, without exception, was faced within the sun rising arc. And essentially, this is purely statistical evidence, but it's basically the early statistically verified evidence we have of a burial practice that is clearly related broadly to the sun, to sunrise. And yes, it raises questions and things which I won't go into, but this is really important for that reason. And this was a data-driven approach. This is kind of going back, just simply looking at statistically at alignment data. But it became very convincing. The archaeologists in Spain particularly were very impressed by this, and it convinced many of them, many of the Iberian archaeologists, that orientation was important, and it convinced them for the first time. And in fact, it resulted in one of these sites being put on the World Heritage List later. And one of the other things, one of the one-off things, I have to mention Chanquillo because it's my favourite site, of course. And this was also a discovery in the 2000s, which I was lucky enough to make alongside my colleague Ivan Getzi, who's Peruvian. And this is the site, for those of you who don't know it. We discovered this in 2005. The site was known, but basically it's these temples in the, oh yes, you can see the pointer. This hill with 13 towers on it in a line. It's a natural hill, roughly north-south facing. And this tower, it looks like some sort of dinosaur in the landscape, doesn't it? But they built these towers on it, surrounded by plazas where ceremonies were held, and a huge fortified temple, it's called, at the top of a hill overlooking it all. But the point being that there's an observing point, there's an open doorway that we know was important. There were ritual offerings found there in the digs. From that point, one or at most two people would look and see the towers forming the horizon like this. These towers are, I mean, you have to imagine them fully built. They were collapsed at the corner. They're being restored right now. They're huge. This perhaps gives you a better idea. So about 6 meters on a side, up to 4 meters tall, originally flat topped with a staircase going up and down along them. So people could parade along all of them. But the point being that from that observing point, looking out to the towers, you see the sun rising over the entire rising arc of the sun, so that between the two solstices, the sun is rising over all these towers and gaps between them. And you see how the natural hill on the left here forms essentially the 13th gap. And those gaps in the middle here, when this was built up and those gaps were vertical, you would basically see the sun rising. Oh, sorry. Well, okay, I'll leave that. Sun rising in a gap. 10 days later, it would rise in the next one, and so on. And it would slow down at the ends, of course, towards the solstices. This was some sort of, this was a monumental solar calendar, and this would time things to the day. It's not a calendar in the sense they divided years. There's no evidence they divided years in a particular way, but they would certainly know that a certain day had recurred when the sun rose in a particular gap or a particular position over the towers. And that monumental solar observatory was discovered in 2005. So again, we're now seeing sort of one-off sites with different interpretations, and the cultural interpretation of that relates to warfare. It was a time of huge change at the time. It was a time of great turbulence, in fact, and the site really only operated, as we now know, for about 2 generations in that time before it was sacked. But obviously the timing of the ceremonials was hugely important, and people came from a long distance. We've got evidence of feasting, music, and so on going on in the plazas at the times of these ceremonials. So that, again, one-off sites, but more culturally embedded conclusions, I think. Still going around the same circles? Well, yes, I think we were. And one instance was this one. I have to mention it. I don't know what's happened to the words that should have gone with this. I think for some reason they've come out in, I think they were in blue and they've disappeared completely, but never mind. So this is the, this is the Nebra disk. It was discovered in Germany, out of context because it had been actually stolen from a site and turned up later, thought to be Bronze Age, possibly Iron Age, but it's certainly a huge, like a bronze plate, probably some sort of shield, this sort of dinner plate size. It's in bronze with these gold inlays, and of course something that looks as if it has to be the sun and the moon, or maybe it's a full moon and a crescent moon. People debate whether this is a boat or, if you turn it the other way up, a rainbow. And these things, which one assumes are stars, maybe that little cluster of 7 there is meant to be the Pleiades. This was interpreted when it was first seen as some sort of measuring device, and the idea being that you could actually map the sky. It's some sort of sky map. It was also interpreted, there are gold plates, one on each side. You see this one, the other one's gone, which just happened to broadly be equal to the solar and rising and setting arcs on the horizon. So it was suggested that this was some sort of instrument that you could get your orientation and so on. It's been known since that the thing developed in stages, that some of these bits and pieces were added on later. But the important thing I think to notice here is that it's not an sign. Sure, this astral symbolism. I mean, you can't see this and not think stars and maybe sun and moon, or full moon and crescent moon. But the stars aren't distributed like that in the sky. No way is this any sort of a star map. Maybe that cluster means the Pleiades, but it's symbolic, so on. It's an astral symbol, and I think most of us would now believe this is, yes, of course, it's powerful astral symbolism, which is presumably empowering the wearer. Maybe it's some sort of shield helping to protect them, but it's not some sort of instrument and sort of some precise astronomical instrument, as many people were trying to argue. And while I'm on this one, you thought you knew what archaeoastronomy was, just to mention that on the right you see archaeogastronomy. And okay. Yes, definitely blue. Blue is not coming out. There were words in blue. So I apologize now. You may have missed earlier essential words to back up what I was saying that were in blue on previous slides, but never mind. So let's go on to the 2010s, and still going around the same circle. So this is Oxford 9 in Lima in 2011, which was where I delivered those words. Yeah, and you might now start to see a few familiar faces and actually recognize them. It's only relatively recent. Now, by this time, we had several, and sort of during the 2010s, several different terms for what we're doing. So in 2014, the handbook came out, which many of us contributed to, and I edited. But this is like a huge three-volume thing about the whole field. It was called the Handbook of Archaeoastronomy and Ethnoastronomy. I would have been equally happy for it to have been called the Handbook of Cultural Astronomy. People debated the terms. I mean, it had always been worrying people about actually using the word astronomy in here, because, astronomy tends to imply modern Western astronomy, modern Western science. Maybe we shouldn't be using the word astronomy at all. And some people weren't happy with any of the terms, or cultural astronomy of that. Some archaeoastronomers, people like Tony Avini in the States, had talked about preferred to use the word sky watching. Now, many of us thought that's a bit too passive. This is more active. I don't like the term sky watching myself. And more recently, we've had the term skyscape archaeology that's been suggested for some of what we do. Now, the motive behind that is, archaeologists going back a few decades looked at sites and so on. And then it was discovered that they really ought to be looking at landscapes and thinking about how people lived in landscape. Landscape archaeology became a big field and established really in the 1990s and so on. And many of us would say, well, hang on a minute, if you're considering how people perceive the landscape around them and lived in that landscape, you can't exclude the sky, because the sky is an integral part of the world and the perceived cosmos. So you should be thinking about landscape and skyscape together. And the term skyscape archaeology came about to try and convince archaeologists to think about the sky, not just about the land. And that's okay. I fully support that. But at the same time, you actually want it to be called land and skyscape archaeology if you're going to do that. So I think basically all of these terms have some pluses and some minuses. So let's stick with cultural astronomy for now. I'm happy with that. So just to give you some idea of more nuance, right. I've been trying to promise myself that I could actually manage to get through a whole talk without using the word nuanced, and I haven't done it. Anyway, here we go. So more nuanced approaches coming along in the 2020s, and sorry, 2010s. I'm still on, and I wanted to mention some work of Frank Prendergast, who's an Irish archaeoastronomer, which I think epitomises this sort of thing. So we're back in the British Isles, Britain and Ireland, and we're looking at Neolithic tombs, several of which are noted to be solstitially aligned. I mentioned, of course, Newgrange. Here's one in the Orkney Islands of Scotland, which is broadly solstitial aligned, Maes Howe. One in Wales, Bryn Celli V, if you know how to pronounce your Welsh, and so on. And there are a number of others that have been noted. And what Frank did was to look at sites like this, about 200 Neolithic tombs around Ireland. Newgrange itself is one of 3 tombs in the Boyne Valley of Ireland, and the other 2 enormous tombs, Knowth and Dowth, well, they don't repeat the solstitial axis. So Knowth and Dowth both have 2 entrances. One of those is solstitial, but the other 3 are not. They're all within the solar range. And there are other factors at play. And of course, when we're thinking about orientation, it's not, was it astronomical or was it not? Many different factors may have influenced orientation, and also amongst similar sites. And when Frank looked at Irish passage tombs, so as I say, about 200 of these, and so it says it here, 132 of them he found had measurable orientations, and he looked at those. What he found was that a big influence orientation was that people like to orientate their cairns on pre-existing cairns, particularly on hilltops, and that a large number, almost half of them, were actually oriented on existing tombs in the landscape, older tombs, and you can see a nice example there. And only out of all of those 132, there were only 15 that were actually solstitial. So was Newgrange exceptional? Well, no one doubts that Newgrange was intentional, because the architecturally to build it with that solstitial alignment involved a slope in the passage and that roof box. No one doubts that that was intentional. But it's not as if all of these tombs were related to the solstice, nothing like. And in fact, even of those 15, there's not a particular solstice direction. There's some summer solstice, some winter solstice, some rise, some set. They're all over the place. There's some of each. That's a beautiful example there of Knockrow. It happens to have two passages, and they're both on the winter solstice. One oriented to the rise, one oriented to the set. So some clearly do seem to have been deliberately solstitial, but that wasn't the whole picture. And yes, so the point being that if we're thinking about orientation, we have to think of a broader context in which, yes, astronomy may have been part of the picture, but many other things might have been as well. The thing about doing archaeoastronomy is that we're thinking about orientation. Well, things might be oriented in a particular direction for a whole manner of reasons. You know, direction, that's where ancestors were thought to come from, or believed to come from, many different things, many of which are simply not recoverable by an archaeologist. But if they're related to the broader topography, mountains and things, or to the sky, then we can see that, because using modern astronomy, we can turn back the clock, we can visualize exactly what their sky looked like, or the regular motions of everything. So if things are aligned astronomically, it basically gives us a direct view into people's what people saw and perceived in the past. And that's not saying that astronomy was everything, but it's actually giving us a view into an important integral part of their views of the cosmos. And I only want to mention this briefly because I'll be talking a lot more about this on Friday, but just to say that this was another project I was involved in, which I think epitomizes, again, this sort of broader approach. Somehow, this balance between trying to be, if not totally statistically objective, but at least to be trying to make sure that we are actually looking at the evidence and we're not just selecting what fits our theory and ignoring the rest. But at the same time, trying to be more culturally sensitive and taking into account other forms of evidence while we interpret it. So work in the Hawaiian Islands that I was involved in for several years together with an archaeologist, Pat Kirch, looking at orientations of monuments. There are many of them, but the particular area that interested us was this area in southern part of the island of Maui, Kahiki Nui. And the nice thing about that is that it's not been taken over by the Europeans. There's no golf courses or resorts in that part. It's a landscape that's been largely unspoilt since the Europeans arrived. And you've still got remains of plantations and traditional houses and temples and so on. And in this area, there were about 70 temples. We look at the orientations of them. They fall into 4 broad categories. There's a northern spread, there's an eastern spread, a very tight east-northeastern spread, and then the coastal ones, which are in blue here, can actually a shaded blue. Oh, yeah, okay. I see them on here in blue, you see them in green. Okay. But anyway, those ones are coastal and they're all over the place. We can interpret that because we have ethnohistory. And we know from our ethnohistory accounts that there were 4 principal gods in the Hawaiian pantheon, and they all had different powers and were perceived in different ways, different associations. And you just get the general picture from this that Kane is associated with the east, is associated with the rising sun, Kanaloa with the sea, Ku is the god of war, but also associated with the north direction, the color red. And Lono is the god of dryland agriculture. People often say of agriculture, but it's more complex than that. And basically, we have 4 different types of temple. And going back to this, the northern ones we can then interpret as Ku temples, and they're essentially topographic. They're pointing broadly north to a ridge in the landscape where there are lots of red cinder cones, the color red. It all accords with Ku. The eastern ones are broadly solar aligned, broadly, because rising sun Kane. The coastal ones, kind of lower, they're just where they sit, they face out to sea. So they're all just depends where the sea is and that where they're placed. And then you get this very tight group around east-northeast, which by default must be associated with Lono and the calendar. And the calendar was associated with the Pleiades, particularly. That was how people divided the year. And that east-northeast direction is where the Pleiades were seen to rise. And in fact, we have 1 or 2 of these temples, which are associated with agriculture. We find them at the tops of agricultural areas. And 1 or 2 of them have very nice little sighting devices for first spotting the heliacal rise of the Pleiades. So you see, again, we've got some are astronomical in the sense of relating to stars, some broadly with the sun, others just topographic or just broadly with the sea, a mix. And we wouldn't be able to unpick that without the help of the ethnographic evidence. And again, that's there's a whole book about all that stuff if anyone's interested in Hawaiian temples, and I'll mention this again on Friday. But again, I've got a couple copies of this as well. It just occurred to me I could do the same with this one if anyone's interested in auction these off as well. So that would be great. And while I'm at it, can I just mention this thing, which I keep showing you without explanation to show you the dates. And it's a very strange wall that was discovered in the southern part of Maui again, in that area. Very remote site. Takes you 3 hours in a 4x4 to get there. And it's just an isolated stretch, a very solidly built wall. It was never connected to anything. And we fortunately have a very precise dating for it. We know it was built around 1440 AD, and that's to do with some rather nice scientific techniques. And it also points, it's not quite east-west, it's got this big notch in the middle, but it points out to the Southern Cross, as I've been showing you with all the pictures, and it aligns slightly west of south, so it aligns with the kite shape of the Southern Cross just as it gets upright on the horizon. And as we argued in a paper, taking into account that, together with a whole lot of other evidence about naming things, and the fact that Pat ran into an old an elder in the area who said, oh, he asked what it was, and this guy said, oh, it's the Pa Nana. And in Hawaiian, Pa Nana, well, Pa is Nana is to sight, and a Pa is a wall. There's a sighting wall. And interestingly, the word Pa Nana in modern Hawaiian means a compass. And what we argue is that it wasn't an astronomical instrument. It wasn't pointing at the Southern Cross in order to see it, because the Southern Cross is going across like this. We think it was a memorial, some sort of memorial to voyaging and to voyagers, because the Southern Cross, Newe as the Hawaiians called it, was the symbol of voyaging. And long distance voyaging, as we know from the stories and the oral evidence that's been passed down, really faded out about 1400, around that time. People no longer plied between the Hawaiian Islands and Tahiti in the south. And that, we believe that this was, basically it was a memorial wall, either to voyaging or to a particular voyager, we don't know which. So just because we have alignments doesn't mean we have observatories. You know, there can be a range of different meanings to things, and we've got to be mindful of that. So we're in the 2020s. Are we still going around some of the same circles? Well, we've had some rather strange things happening in Britain relating to Stonehenge. You knew I was going to mention Stonehenge, didn't you, at some point? I can't resist it. Well, now I don't want to speak ill of Tim. He sadly died last year. It's one of our leading Stonehenge archaeologists. And here's the strange thing, because Tim came out with a suggestion in 2022, which struck both his fellow archaeologists and most of us archaeoastronomers as off the wall. And yet it was very seriously put. And his idea was that Stonehenge was an accurate calendar, and that not that it was to do with alignments, but that this was encoded in the numerology of the monument. So what Tim was suggesting was that, well, in the circle, this is a model of Stonehenge as it was originally, or at least when the stones came in. There are 30 uprights in the outer circle at Stonehenge. There's your 30. There are 5 trilithons, arches inside. There's your 5. There are 4 of these little stones, or were, the station stones. There isn't actually 12 of anything, but maybe there was. Maybe they will discover that later. And so by a bit of numerical manipulation, you get 365 and a quarter. So, wow. So maybe they were encoding this sort of calendar. Now, I have to say that back in the early days of archaeoastronomy in the 1970s, we really were so anti-numerology. You can basically prove anything. You know, every time you see 30 dots on something doesn't mean it was a lunar calendar, right? Even that, and that sort of thing. And in fact, I remember there's a guy called Brad Schaefer, who's an astronomer who had a lot of interest in archaeoastronomy. And I remember him giving a paper somewhere, though I've never seen it written up, where he basically came up with an astronomical explanation for every number between 1 and 119, just to prove the point that just counting numbers and things proves nothing. And indeed, I think I worked on it once. I can get the Mesoamerican calendar out of this if I work hard. Without, you know, it's easy to do. So Stonehenge was not a calendar. And I'll be talking in the conference a little bit about what we've been doing recently, but just to emphasize that, I just wanted to mention, well, you know, though we still do look at alignments, and I defend that, but we're not talking about the accuracy. What we need to think about is the precision of alignments. Right. So I assume everyone here knows the difference between precision and accuracy. But if you don't, what you need to do is Google precision, accuracy, Obama, cats. And what that will produce is this lovely little 3x3 table. And so you can see how it works. So Barack Obama is 70.128 feet tall. Very precise, not very accurate, right? Most cats have legs, accurate enough, not very precise. And so, precision is about how you quote things. Accuracy is about how close you are to reality. And of course, accuracy is what we measure. But what I want to do is to distinguish between precision, which is what was important to them. And just because something is very accurate, it may not have been important that it was to them it was that accurate. It's the precision that matters. Anyway, so how I explain Stonehenge, and I'll pop this in here about the relation. This is Stonehenge in its solstitial alignment. The conference I'll be talking about the moon, but this is the well-known alignment of Stonehenge to the midsummer sunrise, midwinter sunset in the other direction. And just to explain this generally to people, I've adopted the just three categories of this, sort of broadly aligned, which is cosmological, as we were talking about earlier. Now, like those Irish tombs, well, no, like the we have a pattern of tomb orientations and house orientations been discovered in the Orkney Islands of Scotland. Houses for the dead, houses for the living. And they broadly fall into four categories, very reminiscent of sort of the Navajo idea of a cosmos divided into four quarters. If you have broad orientations like that, if that's the level of precision, you would tend to think this is cosmological. This is what is defining it. So, you might have a site that's sort of 4 degrees off the solstice, but maybe that meant something to people. That was all that mattered. So that's one possibility. At the other extreme is the possibility I was talking about right at the beginning, as suggested by Alexander Thom, where you have mountains and you pinpoint the solstice in time. But for that, you need to be pinpointing the solstice to like a 50th of a degree, tiny proportion of the. At Stonehenge, we don't have mountains, so you can't do that. But we do have very accurate alignments on the solstice position. So maybe that was the level of precision in the middle. And in fact, we have 2 or 3 other monuments around Stonehenge that have similar alignments. So we believe that. What that's telling us is that Stonehenge did actually pinpoint the solstice in space, if you like, but not in time. And what that means is that effectively it's pointing at where the sun rises for like 2 or 3 weeks around the actual solstice. And that makes sense, doesn't it? Because think of the British weather, it's like this. And that means that if anyone's trying to watch the midsummer sunrise, well, people try it every year, of course, and about 1 in 4 or 5 years they'll actually see it, because you're only going to see a good sunrise once in every few days. Well, for people in the past, that would be the day when they eventually see the sun rising the right direction. That's the time, or the sun setting. That's the time to hold the right ceremonial. Well, there was no exact calendar, but it was a broad seasonal thing, and yes, it was a calendar, but not exact in the sense that we think of it. So I think that sort of, again, that's thinking about things not just anthropologically, but there's common sense when you think about the British weather as well. What these solstitial alignments might have meant. So there's another book about this. So here we have the. Now I'm sorry, I have to figure. I can't offer you this one. I brought 6 copies with me, and none of them got beyond Sydney. I really am sorry about that. So I haven't brought any with me, but you can get these. That's only published a year ago, and it's out there. And that's got lots of stuff about what we were doing at Stonehenge. But not in the last year. That's for the conference. And the last thing, just to round off, how am I doing on time? Oh yeah, just about there. So this is the last thing. I just wanted to mention something else that's happened in the last few years, and that is that astronomy has become part of world heritage and has been recognised. Sites that relate to astronomy, various ways, have started to be recognised as UNESCO World Heritage Sites. And that comes about, it's an initiative that was set up between UNESCO and the International Astronomical Union. It was set up in 2008, ran for a decade. And as a result of that, countries have started to put forward for the World Heritage List sites that have a relationship to astronomy. One of the earliest that happened because of that was Jogger Bank Observatory in the UK, so modern astronomical sites included. And that has also thrown up some interesting issues related to some of the sites that were proposed. And I can mention this one because it's a site in North Macedonia. It's actually a beautiful archaeological site. It's a hilltop fortress. And it was put forward as a Bronze Age observatory. And what was happening, it has platforms and things on this hilltop. And you can see that it has this very notchy horizon. And basically, those are some of the significant sun and moon rising positions that were pointed out. And basically, this is all to do with selection effects. You can see how many notches there are there. This really does not stand up to critical examination. There is no evidence that those particular notches were important. So this site was never put forward. But you see that or the site was put forward, but it was not listed. It was thrown out. And so there's an element of that it's not just all academic these days, that from a heritage point of view, there are issues to preserving sites, and we need to get it right about what was important. More often than not, that is talking to the current present day owners of the sites, and that is the best way forward with most of them. But we have had other things inscribed on the World Heritage List in the meantime, particularly this lovely, absolutely superb cultural landscape in the Gran Canaria and Canary Islands, which contains two very intriguing, very interesting archaeoastronomical sites within a landscape. And the listing is all about the development of that landscape over 1,000 years. But archaeoastronomy is important as part of that. And then Chankillo itself that I mentioned, that got listed in 2021. And then a couple of years ago, a whole range of sites got listed, including a couple of archaeoastronomical ones. So some sites on Menorca that have a significance. That's part of the Hoskin work I was talking about. And also this site in North America, some of the Hopewell sites in North America, which have some astronomical connections too. So what now? Well, I think that's what we're going to be hearing over the next few days and at the conference. So that's where I'm going to finish. Thank you for listening.